All right, here's our video today, Algebra 1 Regents Review, Part 3. If you missed Part 1 and Part 2, there's a link below, somewhere down below. You can find it. So let's continue. We're going to look at questions that have appeared on the Regents over the years, and we'll just look at those questions. So let's start right away. Let's go. Let's get a clean page. All right, and make sure we have our pen going. Why don't we start with yellow? So let's say that you had to solve. Let's say you had this quadratic x squared minus 10x minus 13. And let's say they said solve by completing the square. And we know there's other ways of solving this, but we're going to do what they say, right? Complete the square. So let's do that process. So we know that before we do anything, we should get that minus 13 out of the way, that negative 13. We'll add it on both sides. So now we have that. And remember, when we're completing the square, we're dealing with the b term. So remember, this is the a term, that's the b term, and the third term would have been the c term. So with the b term, we're always going to divide it by 2. And whatever answer we get, we're going to square it, right? So we're taking negative 10 divided by 2. We're going to get negative 5 and square it. And we'll get 25. And it will always be positive. So now we'll take that 25. We're going to say x squared minus 10x plus 25 because it's positive. And we're going to put the 25 on both sides. We'll add it to the 13. So we'll get x squared minus 10x plus 25 equals 38. Now we can factor on the left side. What two numbers will give us a product of 25, positive 25, and at the same time will give us a sum of the b term, negative 10? Right? Well, we already know what it is. It's 5, right? So it'll be x minus 5 squared, because it's x minus 5 times x minus 5. And if you don't know how to factor trinomials, and I have a video on that, you should look at that video if you don't know how to factor that. We'll factor one in coming up. So this equals 38. All right, now we're trying to, again, solve. We want to solve what x is. So if we'll bring a little arrow over here, why don't we change it so we don't get it a little muddy? So we have x minus 5 squared equals 38. And we want to get rid of that square by square root both sides. And this will give us just x minus 5, but this will still give us the square root of 38. It's not a perfect square. So we'll add 5 on both sides. Remember, this is going to be plus minus the square root of 38. So our answer, we're going to have two x's. The first x is going to be, x is going to equal 5 plus the square root of 38. But also, x will equal 5 minus the square root of 38, because we did say plus minus over here. All right, let's get another quadratic equation here, so in case you're unfamiliar with how to factor that. So let's clear that out. Rewind if you need it. And let's go back to yellow. What if we had x squared plus 8x plus 15? So again, remember, that was the a term, that's the b term, that's the c term. These are the terms. And we want to know what two numbers, or the same numbers, but there's two of them, give us a product of the c term and sum to the b term. And this is only if the a term is a 1. So the coefficient is a 1. And there is a 1 here. We just don't put a 1. If you don't see a coefficient, you don't see a number, it's 1. Like sometimes you might see a coefficient of 2, right? In that case, there's a different rule. But for this rule, if the coefficient is 1 on the leading term, that's the leading term right here, there is a 1 there, then you'll do this rule right here. So we know that 5 times 3 is 15. And we know that 5 plus 3 gives us 8. So we're going to use those two numbers. So we'll get rid of that guy. And we know that when we do this, when we factor trinomials, we always have to have two x's right in our binomials. So we're going to have an x plus 5 and an x plus 3. And you can do FOIL to check, right? The first term is f, first term times the first term times the first term gives us x squared. This is the outside term. The outside term times the outside term times the outside term gives us 3x. X and 3 are the outside terms, and 5 and x are inside terms. 5 times x is 5x. And the last term times the last term gives us our 15. So we combine like terms, and we get that. And by the way, since we have x plus 5, we want to know what the zeros would be, just minus the 5. And we know we have x equals negative 5. That's one 0. And the other 0, you can see it, right? X equals negative 3. So this is where that parabola will cross the x-axis at negative 5 and negative 3. All right, let's move on. All right, here's a question. It says the graphs below represent 4 polynomial functions. You see these parabolas here. Which of these functions has zeros of 2 and negative 3? So you're basically finding where on the x-axis, get our pen going here. Oops, we'll get back to that question. Emily wanted us to do this question, but we'll get to it. So where do you see 2 and negative 3? I just look at the axis, and if you looked at it, if you want to look at it, I'll tell you in a minute, just look at it carefully. Where do you see it? Well, right here. There's negative 3. Let's change our pen. Use blue. There we have negative 3, and there we have 2. That's where it is. It's a pretty easy question. Those are the zeros, or the roots. You might hear those roots also. The roots. Not the band on the Tonight Show. No, the roots. All right, here's the Emily question. Let's keep blue. So Emily was given $600 for her high school graduation. Let's clear out the other problem there. And she invested it in an account that earns 2.4 interest per year. If she does not make any deposits or withdrawals, which expression can be used to determine the amount of money she'll have after 4 years? All right, so the initial deposit is $600, and they all have $600. And you'll see this formula here. Let's again keep the blue. So you'll see these formulas where we have the principal, the initial amount, and then you'll have 1 plus r to the t, to the time. And this is, of course, you'll see this if it's in appreciating or if it's increasing. If it's depreciating, like cars, for example, then you'll see a minus sign. So we know that we have 600, and they all show that. And it's going to be 1 plus 2.4%. So remember, 2.4%, you want to make a decimal by bringing it back 1, 2. So you're going to have 0.024. So it'll be 1 plus 0.024, 4 years. So if you look at it, the only one that works is right here. It's not minus, right? Not minus, because minus is depreciating. She's increasing. The interest is increasing. So it's not 2 and 4, and it's not 1 because it's not 0.24, it's 0.024. Remember those with decimals. So it'll be number 3. And if you ever get a question of how much she'll have after 4 years like this, they're not asking you how much she's having. They're just asking you what is the equation So you would just plug this into the calculator. All right, let's look at this question. By the way, the answer of here, where number 2 is missing, but 2 would have been, is it 1 and 3? 1 and 3 only. So let's see what it says here. What are different ways to represent data are shown below? These are different ways, right? We have a dot plot over here. We have a box plot. It used to be called, you probably remember when in middle school, it was a box and whisker, and we have a histogram over here, frequency table. So if we're looking at this, which data will have a median of 2? Right? And if we look at this, if we count over here, remember the median is the middle number. So over here we can see right there that 2 has a median of 2. So we can eliminate the second problem because it only says 1 and 3. This is 1, 2, and 3. This says 2 and 3, and this is 1 and 2 only. So let's see what 1 has. So if we try to count the middle number, right, if I counted all these right here, we have 1, 2, 3, 4, 5, 6, 7. We have 7 numbers there. 1, 2, 3, 4, 5, 6, 7. 7 numbers here. So we can see the median is 2 there also. So 1 and 2 work. But does 3 work? Well, let's look. If you looked at these numbers here, we have 1 for 0. We have 3 for 1. Just look at the chart. You have 5 there. You have 3 there. You have 4, 3, and 2. 2. And if you looked at the data, 3 is in the middle. So it can't be 3. So the only one that works is 1. Remember, the median is the middle number. All right, let's look at this question. At Berkeley High School, Central High School, they did a survey. They wanted to see if students preferred cheeseburgers, pizza, or hot dogs for lunch. And the survey is below. So based on this survey, what percentage of students preferred pizza? So you have to total them, add them together. So here, if you add them together, the totals, here are the totals. Well, we should get our pen working first. Let's use that color. So we'll say T for totals. Over here, we have a total of 68. Add them together. Let's see, we add these together, and we have 74. And we add these together, we have 58. Then we need totals over here, too. Need all the totals. And if we add 32, 44, 24, we get 100. And if we add 36, 30, and 34, we also get 100. So the total would be 200. So what percentage of students preferred pizza? Well, we know 74 wanted pizza out of 200. So if you just divide that out, you'll get 0.37. Move it twice, and it's 37%. And in this case, they said, what percent? There it is, 37%. All right, let's say you had these quadratic equations. And which color should we use? I'll just keep that color. Let's say you had f of x equals negative 5x squared. And now let's say you had also g of x that equals 0.5x squared. And we'll use h of x. And you usually see f, g, and h when you see these. And let's say that's 3x squared. And they're asking you, let's say in this question, what is the order? What order would you put these in, arranged from the narrowest graph? So we want them from the narrowest graph to the widest graph. So if you graph these on a calculator, or if you just graph them on paper, one will have a narrower graph than the others, and one will have a wider graph, and one will be right in the middle. It's important to know this right over here. The narrowest graph, has the largest coefficient, has the largest coefficient. Largest coefficient. And we mean absolute value coefficient. Absolute value. So if you look at f of x, right, f of x has an absolute value of 5, where g of x has an absolute value of 0.5, and h of x has an absolute value of 3. So who has the narrowest graph? F of x has the narrowest graph because it has the largest absolute value coefficient. So this order would be f of x, then what do you think? H of x, and then g of x. So g of x will have not the narrowest graph, but the widest graph. All right, let's do one more question. Let's clear that out. Why don't we use white? Why not? So let's say you had, let's make sure our pen's working. Get that pen working. Let's say you had 3x squared plus 7x minus 6 plus 2x cubed. And they want this written in standard form. Now, when you write things in standard form, they have to be in descending order, the exponents. So if you put it in standing form, they also got to ask you, what is the leading? What is the leading coefficient? The leading coefficient. So first of all, if we put this in standard form, it's going to be 2x cubed, right? Because this will be, the 3 is the largest exponent. So it's 2x cubed, descending order now, 3x squared plus 7x minus 6. And the leading coefficient is the one that has the highest exponent. So the leading coefficient will be 2, right? It's the leading one. This will be a third degree polynomial. And it's third degree because it has a 3 as the leading exponent, and the leading coefficient is the one with the largest exponent. All right, that's part 3. We'll do part 4, do more questions.